Good day to you out there. You are welcome to Science Explained. Today, I want to treat with you the applications of mole concept. That is, the areas of field of chemistry where mole concept can be applied to solve experimental problems. At the end of watching this video, if you find it interesting, please do not hesitate to subscribe to my channel, and as well share and like the button. Now let's start with this question on the board, but you can give it a try before I move in. Try your best. Okay, now how do we go about solving this kind of problem? We first of all go and look at the equations given. Is it balanced? If it is not balanced, then we have to balance it. Obviously, it's a balanced equation. Now, we are looking for the mass of sodium sulfate, that is Na2SO4. We are looking for the mass of this that will be produced by 0.5 mole of sodium hydroxide, which is this. But according to the reaction, that's the first thing you do. How many moles of sodium hydroxide produces how many moles of sodium sulfate? It's obvious that 2 moles of sodium hydroxide produces 1 mole, because there is an invisible one here. 1 mole of sodium sulfate. So that's what I'm going to write down. 2 moles of sodium hydroxide produces 1 mole of sodium sulfate. Now, since the information given about sodium hydroxide is in form of mole, I will not bother to change this. I will leave it as mole. But the question asked me to find the mass of sodium sulfate, which is on this side. That means I need to convert this 1 mole of sodium sulfate to mass, that is the relative molecular mass. Therefore, it means 2 moles of sodium hydroxide will produce, that will be 23 times 2 plus 32 for sulfur plus 16 times 4 for oxygen. So whatever we get here is the relative molecular mass of sodium sulfate. Let's do the calculation. Two moles sodium hydroxide will form 142 grams sodium sulfate. The sum of all this is 142 grams. So now, but 0.5 mole of sodium hydroxide is given. So 0.5 mole sodium hydroxide will now produce what mass of sodium sulfate? Let's use a letter. Let's say x gram. Then by cross multiplication, don't forget the division line. So x times 2 will give 0.5 times 142. Divide both sides by 2. So what will be the value of x now? X will be equal to 0.5 times 142 over 2. This is 71. So that will be 35.5 grams of Na2SO4 that will be formed. Let's have a look at another question on application of mole concept. Let's have a look at this example question. We are given impure calcium triisocarbonate 4 to react with hydrochloric acid, and carbon 4 oxide gas is liberated. Of course, anytime an acid reacts with a triisocarbonate, carbon 4 oxide is always liberated. That is one of the major tests for an acid. All right, this is the equation of reaction, the balanced equation. So, but it is important for you to know that whatever is taking place here is taking place from the pure side, not impure. That means it is the pure calcium triisocarbonate 4 that will produce pure calcium chloride and liberate pure carbon 4 oxide gas. That means, what do I do now? It means that this 1.4 grams, which is the impure calcium triisocarbonate, cannot liberate this carbon 4 oxide gas. So what I will now do is, I will use the number of mole of carbon 4 oxide liberated to get the pure side of calcium triisocarbonate that produces it. Okay? That means, according to the reaction now, according to the reaction, or to the equation of reaction, 1 mole of calcium triisocarbonate 4 is producing 1 mole of carbon 4 oxide. 1 mole CO2 is liberated by 1 mole calcium triisocarbonate 4. I will convert this one to mass. Why? Because if you look at this information, we are given the mass of impure calcium triisocarbonate. That means I work in terms of mass with calcium triisocarbonate 4, while I will let this one remain in its mole. Why? Because we are given 0.01 mole. Therefore, 1 mole CO2 will produce, I will find the relative molecular mass of this. That will be 40 plus 12 plus 16 times 3. These are the atomic masses of the constituent elements. So I'm going to add everything together. 1 mole CO2 is produced by the addition of this will give me 100 grams of calcium triisocarbonate. So if 1 mole of carbon 4 oxide now is produced by 100 grams of calcium triisocarbonate, the pure carbonate now. Let's now see the mass of this that will produce 0.01 mole of carbon 4 oxide. So 0.01 mole CO2 will be produced by, let's say, Y grams of calcium triisocarbonate. So let me draw the division line. Then we cross multiply as usual. So from the cross multiplication, Y we multiply 1. Y times 1 equals 0.01. We multiply 100. So that means, which will give me 1 gram. Therefore, Y equals to 1 gram of calcium triisocarbonate 4. So in this case now, it is 1 gram of pure, this is pure. Please take note of that. Everything I'm working on here is based on pure side of calcium thiazocarbonate 4. So now, 1 gram of pure calcium thiazocarbonate 4 is the one that produces 0.01 mole of carbon 4 oxide. To now find the percentage purity, we need to find, that means we need to use the formula, Roman figure 1, percentage purity of calcium thiazocarbonate 4 equals to mass of pure over mass of impure times 100 over 1. That is how to find percentage purity. So pure what? That's pure calcium thiazocarbonate 3, impure calcium thiazocarbonate 4 rather. Calcium thiazocarbonate 4. All right. By substitution now, percentage purity will be, what is the mass of pure? That is 1. Mass of impure is given to be 1.4, according to the information we have in the question, times 100 over 1. And that will give us, let's use our calculator to get that. That's 71.43. 71.43%. Yes. That is the percentage purity. Okay? Now, percentage impurity can be found in 2 different ways. Roman figure 2. Percentage impurity will be 100% minus percentage purity. You know, when we remove purity out of impurity, we have impure left. So percentage impurity is 100% minus percentage of purity. That means 100% minus, what is the percentage here? 71.43. And what would that give us? (28.57). 28.57%. That is one way, which is the faster and the better way. But for confirmation, let's say how we can use another formula also to get it. Alternatively, percentage impurity equals mass of impurity over mass of impure times 100 over 1. Okay. How do we get mass of impurity? Mass of impurity will be equals to 1.4 minus 1, which is 0.4 grams. Do not forget, 1.4 is the mass of impure. 1 gram is the mass of pure. That means if we subtract that one from this, whatever we have left is impurity, which is 0.4. So 0.4 will now replace mass of impurity. Therefore, percentage impurity will be 0.4 over mass of impure, which is 1.4 times 100 over 1. Let's see what that gives us. It must give us this. Yeah, that's 28.57. As you can see, it's confirming this. So that's how to find percentage purity or percentage impurity. This is where I'm going to stop on the application of mole concept. In my next video, I will be dealing with heat change or enthalpy change. Please do not hesitate to subscribe and share, then press the like button. If you subscribe to my channel, you will be getting the notifications for subsequent videos as they are released. Stay safe. Thank you.